out. All right, absolute value equations. So hopefully we all remember that absolute value is the what? Distance the number is away from 0. So absolute value is distance, and distance is always positive. Distance is always positive. So the absolute value in and of itself is a positive value, all by itself. Now there can be a negative in front of the absolute value, which means a -1 times it. But in and of itself, just all by itself, an absolute value quantity is always positive. Absolute value quantity is always positive. That's the concept. All right. So we need to look at this aspect. If this next thing doesn't make perfect sense to you, it won't kill you. Applying it is really the key, but let me try anyhow. All right, so we've got two situations and two possibilities. So when a variable is inside the absolute value symbol, you got a variable in there. There are two solutions. Now that's important to remember. It's really important that when you see an absolute value equation, you think two solutions. And that's what I'm talking about here, absolute value equations. So you get the variable, it's inside the absolute value, and there's got to be two solutions. There just has to be, all right? So one of them, the absolute value of x will equal x. That's not hard to figure out. If x is positive, for example, what if the x were a 7? What's the absolute value of 7? 7, see, it's the x, right? You know, if x is 11, what's the absolute value of 11? 11, see the value of x, right? Because x was 11. So whenever x is positive, the absolute value is positive. You know, in this example, n must have been 4 if we're thinking that it's positive. Well, here's the second scenario. The absolute value of x equals, and I'm going to use my red right here, negative, and then back to blue, x. If x is less than or equal to 0, meaning x is negative. All right, so to understand this one, what's the absolute value of -3? 3. Mathematically, how do you get a positive 3 out of a -3? You do negative the -3. Right? Negative the value of x. What was x? -3. What's negative the -3? +3. Right? I mean, that's just the way it is. If the variable or what the value inside the absolute value is negative, then the other solution comes from minus that, because it's going to be minus to minus. Again, the thought here is, let's suppose if x equaled -3, right? And you can write this, then the absolute value of -3 equals, I'm going to take my red, minus, parentheses, a -3, right? Minus x. Okay, so we all know the absolute value of -3 is 3. That is a piece of cake. We wouldn't bother with minus a -3 to do that. The problem is when it's a variable, we don't know its value. And what we have to do in the math is come up with both solutions. So one solution comes from simply taking x. And the other solution comes from -x. And two solutions. And so that's what you got to remember. You got to get in your mind when we're doing absolute value equations that there are two solutions. Two solutions. Two solutions. Okay, so something to look back at if you forget, or something to review when you're reviewing for a quiz or test. All right, so what do you do when you solve? First off, you want to isolate the absolute value. Look, that's not hard to remember. When we're solving an equation, what are you after isolating the variable? Well, to solve an absolute value equation, first you have to isolate the absolute value. Meaning, get the absolute value all by itself on one side of the equal sign, right? Isolate it. Okay, next. Remove the absolute value and solve. That's the first equation. So number one, and I'm going to write out here first equation, right, is simply remove the absolute value and solve. I'm going to take my red. The second equation is remove the absolute value symbol and replace it with parentheses and put a negative in front. That's that negative part. Put a negative in front and solve. That'll give you the second equation. Okay, so let me pause. Honestly, most textbooks, and probably your textbook, treats the second equation a little differently. They tell you to put the negative on the opposite side of the absolute value, which can technically be the same thing. The reason I keep it with the absolute value is I want to make sure that you get inequalities correct later and you solve them the exact same way. My technique of teaching math is always, if I can teach you less things that solve more things, you're better off because then you have to remember less, right? If I can teach you a method that will solve two different things, I'm better off than teaching you a method that solves one and then a second method, a different method that solves another. Because now you only have to remember one thing instead of two. So for that reason, that's why I teach it the way I do, because this will not only then solve equations, it will take care of inequalities for us as well. So that's what I'm after. It really mathematically is the same thing, but just saves you that. All right, so let's get to the nitty-gritty. And I'm going to have to get rid of my shade so I can move this up and it doesn't do crazy things on me. Let me grab my pen first so it doesn't want to pop back on me. So let's try this example. All right, so you can see we have an absolute value equation, yes? Look, this has to be your first thought. Two equations, because two solutions. You have to think that. If you don't think two equations when you see absolute value, you know what you're going to do? You're going to give one equation, one solution, and you're only going to have half the answers. You don't want to do that. Okay, so the first thing is to isolate the absolute value. Is the absolute value isolated for A? And the answer is no, right? Is the absolute value all by itself on the left? No, we got a 4 there, right? So what we're going to do, move the 4. You already know how to move a 4, right? Add -4 to both sides. So now the next line is the absolute value of 4x minus 2 equals 6, right? Do you agree? We added -4 to both sides. Okay, now we've isolated the absolute value. Great, that's what we were after. So now I need my two equations. My first one, all I do is remove the absolute value and solve, right? But I like to write the second one before I get started. And I'm going to do the second one in black because I don't want to forget that second one. So remember, the second one is replace the absolute value with a parentheses, right? Put a negative. I'm going to do it in red so it stands out. Put a negative out in front and then solve, right? The two ways, equation 1, equation 2. Okay, now the rest is easy. All right, so on the left, add a +2 to both sides. You get 4x equals 8. Divide by 4, you get x equal 2. All right, so we moved it -2. We divide it by 4. Voila, x equal 2. Hey, let's pause a second. Let's go back to the original. Let's make sure that solves it. 4 times 2 is 8. 8 minus 2 is 6. The absolute value of 6 is 6. 6 and 4 equals 10, right? I'm looking at the original, right? Trying the value, right? So you end up with 10 equals 10. It works, right? Solve the second one. All right, be careful. You got to distribute your negative. So it's a -4x plus 2, right? You got to distribute that negative to both quantities. Now again, add a -2 to both sides. And you end up with what? A 4, and divide both sides by -4, and you get x equal -1. Agreed? Okay, so again, look at the original absolute value. That x right there would be a -1, right? 4 times -1 is -4. -4 and -2 is -6. What's the absolute value of -6? 6. What's 6 and 4? 10. See, we're at 10 again. See, we found, because what's that absolute value worth? 6. And we found it when it's +6, and we found it when the variable makes it -6. See, we found the variable that will make it +6, and we found the variable that will make inside the absolute value -6, the two possibilities. That's what the math is doing. All right, once we got them, that's it. Those are the two solutions, and we're rolling on the next one. And again, any quiz or test, when you have time, and if it's not big fractions and stuff, you can go back and stick them in and make sure you're correct if you got time. Again, remember, you got to wait till the end. Tim?
How did you get that minus on?
All right, so at the very end, Tim, I had a -4, so I divided both sides.
Oh, the one in front of the parentheses.
Oh, that you put in. That you do. So that's something you have to know, and that's this part right here. Put a negative in front and solve. So that's something you have to add to the equation, something you have to know to do. Rachel.
For the first equation, how did you keep the -2? I thought the absolute value that way wrong here.
Well, remember, we solve the absolute value, and the procedure to solve is the first time, get rid of the absolute value and just solve. That will allow you to figure out the first solution. The second solution is to get rid of the absolute value and put a parentheses and negative in front and solve, which allows you to find the second value. So it's a mathematical procedure that is allowing you then to figure out what the absolute value is. I don't know if that answered your question. Do you want to try again, maybe?
I just don't see why the absolute value lines have to be okay that
Well, technically we are. So let me go back to showing you the solutions again. So here was the first solution. This was a 2. And so you can see we end up with the absolute value of 6 plus 4 equals 10, which is 6 plus 4 equals 10. And sure enough, we found the correct solution, 10 equals 10. And the second time, now we got a -1 here. And now we have the absolute value of -6 plus 4 equals 10. And the absolute value of -6 is 6. And sure enough, 10 equals 10. So we are going about a mathematical process to figure out what will make these absolute values, in this case 6, in this case -6, to find both possibilities of the solutions. Again, I don't know if that made sense either. But it's just a mathematical process. So we're removing the absolute value because we're doing the process that allows us to remove it to find its values. I don't know if that helps. But that's what we're doing. It's a mathematical process that allows us to remove them to find the values. And if they're still there, then we wouldn't be able to solve. And so it's a mathematical process to remove them to be able to solve. Okay, let's try the last one. So I'll tell you what, I'm going to work it up here. You can work it at your seat. If you want help, you can look up. I'll include all the steps. So if you want to try it on your own, go ahead. Remember, first thing, you got to isolate the absolute value. So again, I'll put all my steps. But if you can do it, go ahead and do it. First step, isolate the absolute value. So once you have the absolute value isolated, you might want to look up to make sure you have the right absolute value isolation before you find both solutions. Right? You had to move a thing added to the absolute value by adding its opposite. You had to move something multiplied. You either multiply by the reciprocal, take the shortcut, right? Divide both sides, right? Same process as if those were multiplied times a variable. Exact same process. No difference. No difference. right, this one's nasty fractions on the first one. And the second one too. Wow, it takes a long time to show every step. Aren't you glad we're in Algebra 2 to where we don't have to do that anymore? All right, so n equals negative 7/3. All right, so two fractional answers. 5/3 is going to allow the left-hand side to equal negative 15, and negative 7/3 is going to allow the left-hand side to equal negative 15, right? So we got to get negative 15 equals negative 15. And we're trying to find those two values inside that absolute value. So let's see, the absolute value actually ends up being, oh, this isn't so hard. That's a 5 plus 1, that's a 6. The absolute value of 6 is 6. Negative 2 times 6, negative 12. Negative 12, negative 3, negative 15. When it's a negative 7/3, the 3 cancel out. You get negative 7 plus 1. I just happen to do 6 and negative 6 again. I don't know why. It's my brain. Must be short-circuited. All right, every absolute value won't end up equaling negative 6. Only those two. You got the procedure, but you got to remember, 2. You just got to follow procedure. All right, everything else we know how to do. Everything else we know how to do. All right. Remember inequalities? Well, all right, so question of the day today, right? We were doing SAT practice before class started. It was Khan Academy, and the question involved an inequality, and the variables disappeared, right? And we learned if the variables disappear and the solution's true, then it's all the real numbers. And if the variable disappears and the solution's false, it's no solution, and that's why that was no solution. Well, you have a situation as well with absolute value. All right, so you got to be aware of this special situation. When the absolute value is isolated, it cannot be, let's change the b to equal. It cannot equal a negative quantity. That's a lot more words, but it's clearer. Quantity. It cannot equal a negative quantity. Okay, so watch what happens here. I'm going to go to isolate the absolute value. So hopefully you would agree I'm going to add a negative 8 to both sides, right? All right, I'm going to go up to the right where I have more room. So now I have the absolute value of x equals negative 3. Do you agree? Now, I don't want to go any farther. Now, I don't care if that's the absolute value of 7x plus 4 equals negative 3. I don't care if it's the absolute value of 37q plus 13.879 equals negative 5. I don't care. Because here's the problem. When can you ever take the absolute value of something and end up negative? Is it possible? It's impossible. Because absolute value is distance, and distance is always positive. So we can't end up negative. So this is impossible. It's impossible. You can't take, and it's because of this negative. So what's the solution? No solution. You can say the null set if you want. Same thing. No solution, right? There's no solution. So be aware of that. All right, so hey, if you're going through, now remember, notice what I said. When the absolute value is, what's that word? Say it. Isolated. You got to wait until it's isolated before seeing if the other side's a negative, all right? It's when the absolute value is isolated. If the other side's a negative, it's no solution. It's impossible because you can't take the absolute value and get a negative quantity. All right, so keep that in mind. Stop at that point. Don't split that up and do both ways. You're wasting your time. By the way, the math will give you an answer, but they'll be wrong. You stop and say, yep, no solution. Don't need to do any more. I'm done. Rolling on. All right, next situation. When there are variables on both sides, it's possible to have, I'll take my blue, extraneous E-X-T-R-A-N-E-O-U-S. E-X-T-R-A-N-E-O-U-S. Extraneous solutions. What in the world are extraneous solutions? Simply, these are solutions that don't work. They don't work. What? I thought math was foolproof. No. You know what? The higher up we get in our math, we can begin to find some things that don't work out. And even though we'll do everything correct mathematically and use things that we've learned that work every other time, the higher up we get in our math, we begin to find, here's an exception. This sometimes doesn't work. And therefore, then, I have to be careful to check to make sure my solutions work. So when you have this situation, and what's the situation I'm talking about now? Variables on both sides. Notice here we have an absolute value with variables on both sides. In this situation, we have to make sure our solutions work, because they may not. We solve it the same way, but we got to, at the end, put them back in the original, see if they're good. All right, so let's try it. All right, so already the absolute value is isolated, yes? Okay. Are there variables on both sides? Yes, so we're in the condition. What do? We got to solve it. So the first time, just remove the absolute value and solve. And again, I'm going to use my blue. I always like to write the second one right away before I solve the first, so I don't forget. I switched my colors from blue to black, didn't I? Who cares? All right, got 1 and 2, right? All right, stay with me on the left-hand side. All right, remember, variables on both sides. First thing you want to do is get all your variables on one side. I'm just going to move everything to the left, right? That gives me an 8x on the left, right? Because I add a positive 5x to both sides. Move the 1. That gives me an 8 on the right, right? And now divide by 8, and x is 1. Is everybody okay with that? Okay, focus your attention back on the original, right? Look in the box here. Right, we're back on the original. I'm looking right here. Okay, so let's go ahead and put 1 in. 3 times 1 is 3. Don't do this, just look. 3 times 1 is 3. 3 and 1 is 4. The absolute value of 4 is 4. So the left is 4. Put 1 in for this x. 5 times 1 is 5. 9 minus 5 is 4. It worked, didn't it? That one's good to go. All right? We like that one. It worked. And again, you just got to check. You just got to check. That one worked. All right, let's solve the second one. This is a negative 3x minus 1 equals 9 minus 5x, right? Distribute your negative. Add a positive 5x to both sides, you get 2x on the left. Add a positive 1 to both sides, you get a 10 on the right. Move the 2. By dividing, you get x equals 5. And again, if you guys are thinking as I'm saying them, you should be looking at the problem yourself, so that you're not copying your thinking. Okay, so now I got to put that 5 back in, right? So I got to put a 5 here. So 3 times 5 is 15. 15 and 1 is 16. The absolute value of 16 is 16. The left is a 16. Put a 5 in here, right? 5 times 5 is 25. 9 minus 25 is what? Negative 16. Did that work? Extraneous. I cross it out. I don't include it. It's an extraneous answer. It doesn't work. It's not true. Now, the math was right. But again, it was a situation where it doesn't work mathematically. When do you have to go through this? When there's variables on both sides. Which, by the way, let me stop for a second and throw a little plug in. All right. So the other day when we did conjunctions and disjunctions, remember we had 4 different kind of conjunctions, 4 different kind of disjunctions. And now we get to absolute value, and now we got to remember to isolate it. We got to put the negative, the parentheses, we got to do two ways. Now we got to remember if it ends up isolated, it's a negative, it's no solution. Now we got to remember if there's variables on both sides, we got to check the solutions. But you don't have to study for math. You can't study for math. Who studies for math? How in the world are you going to remember all that stuff without studying? How are you going to do it? And the answer is, you're not. You're just not. You're not going to remember it without studying. You're just not. It's too much stuff. All right? It's not hard. I think you guys are kind of got the grasp of what's going on, but you got to remember it. All right. Enough of the plug. We got a little bit more to finish off here. Do I have another page yet? Oh, man, I got to roll. All right. Let's get motoring. Yeah. All right. Distance between 2 points along the line. All right, distance, you guys just came out of geometry, and you know that distance equals the absolute value of one of the coordinates minus the absolute value of the other coordinate. And you can find the distance. It's just a mathematical way of coming up with the distance between 2 points. So if I wanted to find the distance between A and B, I'm going to do the absolute value. All right, what's the coordinate of B? It's a 4. Now be careful here. The formula has a minus, and that's why I'm doing it in red, right? That's the minus of the formula. And now what's the A coordinate? -5, right? And now we end up with the absolute value of 9, right? Minus a minus a plus, and the absolute value of 9 is... And how far is the distance between A and B? It's 9, right? And you might say, "What? I could look at the stupid number line and tell you it was 9." Okay, we're learning the formula, so you don't have to make a number line. All right? And really, distance isn't a big deal. It should never be a big deal. Once you get numbers in your head, what's the distance between a -10 and a 5? How far is it from -10 to 5? No, all the way from -10 to 5. 15, right? -10 to 0 is 10, and 5 more, 15? I get it. Well, all right. Use the formula if you can't do that in your head. All right, the other thing you should know is midpoint. Midpoint. And you guys did midpoint last year. You did. Midpoint is the average of the coordinates of the endpoints. The midpoint is the coordinates of the midpoint. That's what we're trying to find, the coordinates of the midpoint. The coordinate of the midpoint. All right, so the formula is really, really easy. It's take the coordinate of A, add to it the coordinate of V, and if it's an average, you're dividing by 2, right? It's just an average. Right? There are two things, you divide by 2, right? Isn't that how you do an average? Got 7 numbers. How do you find the average? You add up to 7, you divide by 7, right? We got 2 things. How do you find the average? Add the 2 things up, divide by 2. All right, so midpoint here, pretty easy. Hey, it doesn't say which one is A and B. Can't do the problem. I'm stuck. Go on. All right, it doesn't matter which one's A and which one's B. You have 2 points. All right, one's 11. The other's a -18. It's divided by 2. And when you're done, you're going to find that the coordinates of this midpoint is -7/2. Right?
It's a -11.
Yeah, it's a negative.
Good, -11. All right, the eyes are failing me. So how about -29/2? All right. Which is what, -14.5? And that would exactly be the case. You're just adding -11 plus -18 divided by 2. You find the average. Hey, let me show you it on the number line. The example here. You agree that that's a -7, right? And you agree that that's a 3. -7 plus 3 is a -4. -4 divided by 2 is a -2. Is that indeed the midpoint? Right? -2? And it is, right? It is what? 1, 2, 3, 4, 5 that way, and it's 5 that way, right? Midpoint. And so indeed the formula works, and you guys did that in geometry, right? Do you remember doing that in geometry? You did do it in geometry. You did both of those. Okay. Well, what about absolute value format? All right, so that's the midpoint right there. So I'm going to write midpoint coordinate. Midpoint coordinate. And I can slow down a little bit now and try to absorb this last little bit. All right, P is the distance from the midpoint, to either endpoint. Distance from the midpoint to either endpoints. All right? So X is P units away from the midpoint on a number line. That may not mean anything yet. That's okay. Don't worry about it. That statement may mean nothing to you. Don't worry. It wouldn't mean anything to me yet either. Hold on, though, in a minute. Hopefully it will. All right. So A says, write the absolute value equation when the solutions are -4 and 6. You're like, how in the world am I going to do that? Because this is a pattern. All right, so watch. Let's first off find the midpoint. And this is an easy one. Can we look and find the midpoint? Right, it's going to be what? 1, right? And again, you can do the midpoint formula, or you can count because we have a number line. But the midpoint is 1. Is everybody okay with that? Right, midpoint of 1. Okay, what's the value of P? How far is it from the midpoint to one of the endpoints? 5, right? Right, from here to here is 5. Therefore, that's P. Or you could do the other side, right? From here to here is 5, which is also P, right? All right, so just for clarity's sake, use your color. I'm going to go absolute value of X. I'm going to go black minus. I'm going to go green M. I'm going to go black absolute value, black equals, and red P. All you need to write the absolute value equation is the value of M and the value of P. Do you know those values? Stick them in. You got it. You're done. So what is M? M is a 1. What is P? P is a 5. Oh, I wanted to write that last one in red. Stay with my colors. Right. Hey, we just wrote the absolute value. Now get this. All right, big concept. If you mathematically solve this, guess what you get? You get -4 as one solution, and you get 6 as the other solution. They're the solutions to the absolute value equation. Try it out. All right, stick -4 in. -4 minus 1 is a -5. Absolute value of -5 is 5. See, -4 solves it. And the other one was what? 6? 6 minus 1 is 5. What's the absolute value of 5? 5. And 6 solves it. See, we found the two solutions. Okay, so before I go any further, don't write this. Just watch for a second. All right, you ready? Just watch. Here, it doesn't matter. I'm going to go, let's see, I'm going to go -3 equals 7. Let's suppose you had an absolute value like that. Okay? What's the midpoint? What's the midpoint? 3. The negative's part of the formula, right? That's why it's in black and the M's in green, right? The negative's part of the formula. Value of the midpoint is? How far does it take to go from the midpoint to an endpoint? So therefore, if I'm at 3, one answer has to be 10. If I'm at 3, the other answer has to be, you just solve the absolute value. Huh? If you understand that, and if it's that scenario. Now, I must tell you, everybody look, if there's a coefficient to the variable, now things are a little bit more complicated. Can you still do this? Yes, but it's not our design to deal with that yet for you. By the way, you could play with it and figure it out yourself. It's not extremely complicated. We just aren't designed to deal with it quite yet with you guys, all right? So just be careful if there's a coefficient in front. Don't try to do the shortcut. But if there's not, hey, that's what's going on. Two solutions, 10 and negative 4. Voila! We got it because math's awesome. All right, one more example. Write the absolute value equation. So again, what are you going to find? You're going to find the midpoint, right? And what else are you going to find? The distance from the midpoint to one of the endpoints, right? And we already know the solution to this absolute value is negative 7 and 1, right? Anybody got the midpoint yet?
Negative 3.
You guys agree with Wesley? Negative 3? All right. And how far is it to either endpoint? You just need to do one because it's the same both ways, right? So I showed you a minute ago both because I want you to make sure you understood it's both ways, but you only need to find one. All right, so be careful here. Finish this one off. I dare say half of you are going to get it wrong, even though we just did negative 3 and we just did 4. I dare say half of you are going to get it wrong, so don't be in that half, all right? Go ahead, finish it off. Finish it off. All right, you guys all have your absolute value? What do you mean no? You're putting in negative 3, you're putting in 4. Come on. What in the world? So here's usually the mistake students make. Do you agree we still have that black negative? We should. And then do we have the negative 3? We should. The rest is easy. P is a 4, right? So how many wrote x plus 3, absolute value of x plus 3 equals 4? About half of you, right? Maybe a little over half, all right? Right? Because the negative is part of the formula. That's the thing that Justin just said a minute ago when he wanted to say the midpoint was 3 when negative 3 when it was positive 3, right? Negative is part of the formula. So be careful. Don't write this. If you had something like this, what's the midpoint? Negative 1, because that had to be negative a negative 1. Therefore, what's one solution? Negative 1, 4, right? Plus 5 is 4. Negative 1 and 5 more is 4. What's the other solution? Negative 6, right? But be careful. This is really this, but we don't write the extra minus plus, right? We never do in algebra, do we? We don't write that extra. Did you get it, John, by the way? Oh, there you go. All right. So, hey, look. Absolute value. It was a lot today. This video will be on HCS Math Class. By the way, there are quick review videos on HCS Math Class. Algebra 2 is tough. 3 to 4 minute videos of all the key concepts of all the lessons. You need to be careful. There's a lot of stuff to know. All right, you guys got your homework at the bottom. You got to treat it seriously, man. I'm telling you, you got to treat it seriously.